The last example we did, we were finding the equation of the secant line of 6 minus x squared between x equals -1 and x equals 3. Now we want to let's look at finding the equation of the tangent line of the function f of x equals 6 minus x squared at this first value that they gave us, x equals -1. Okay, so we're going to find the equation. Of the tangent line. At x equals -1 on our function f of x, which was equal to 6 minus x squared. Okay, so we needed a point for our equation of a line, and we need the slope. And we already found the point by going in and plugging in x equals -1 wherever we saw an x and f of x. And so again, if we go in, plug in -1 wherever we see an x, we have 6 minus -1 quantity squared. Squaring the -1 gives us +1, and so we get 6 minus 1, which was 5. So again, we have a point at -1, 5. So now to find the equation of the line, we need the slope. And recall the slope of the tangent line was that instantaneous rate of change at this value x equals -1. So we need to find the instantaneous rate of change at x equals -1. Okay, so let me just bring in the equation again. You guys are going to get great at this equation, hopefully. The limit as h is approaching 0 of f of a plus h minus f of a all over h. In our case, for this example, the value we're trying to figure out where it's the slope is, instantaneous rate of change was x equal -1, so a is -1. So we're looking at the limit as h approaches 0, the function f of, well, if we plug in -1 for a, at -1, and then we want to add the h, so plus h, minus f of a. So our a value again is -1, so minus a -1. And we're putting this all over h. If it's helpful for you, then you're going to want to, you can do this in pieces. And so if we wanted to look at, let's do f of -1 plus h. So this first piece of our limit in the numerator. So we're going to go to our function f of x. And wherever we see an x, let's first put in parentheses. So we have, this is equal to 6 minus, I see an x there, I'm going to put parentheses big enough to put that whole expression -1 plus h, and then a square. So let's do some of the work here and distribute. So we have 6 minus. So this quantity squared, we can't just square each entry in there because there's more than one term. So we need to expand this, -1 plus h times -1 plus h. And so we have 6, bring down our negative. Need to be careful because this negative is going to have to distribute to all the terms once we've distributed this out. So I'm going to first distribute my -1 plus h times -1 plus h. So we have -1 times -1, that gives us +1. We have a -1 times h, so that's minus h. H times -1 is negative h, and h times h gives us plus h squared. So we have 6 minus, let's combine like terms inside this bracket. And I'm going to rewrite it descending order of powers. So I'm going to start with my h squared. So like terms, recall, are terms that have the same variable raised the same power. So we have a minus h, that's a -2h. And then we have this +1. This minus side outside, this needs to be distributed to each term. And so this is equal to 6 minus 1 times h squared is minus h squared, negative times -2h, so plus 2h, and negative times +1 is -1. So let's simplify that. Combining like terms, I see that I have a 6 minus 1. So 6 minus 1, that is 5 minus h squared plus 2h. Okay, so from there, let's maybe put that piece in to our limit. So we have the limit as h approaches 0. We just found that f of -1 plus h. Let's rewrite that up here with 5 minus h squared plus 2h. Now let's do the next piece. And then we're going to have a minus. So I'm going to put a minus here. And now let's look at what is f of -1. So f of, if I go in and I plug in -1 wherever I see an x, and my function of f of x, this is equal to 6 minus, I see an x, put parentheses, square it. Replace the x with -1, put that -1 inside the parentheses. We've already done this calculation before. This is 6 minus -1 squared was +1, and 6 minus 1 was 5. So now go in, we're going to replace this f of -1 with 5, so -5. And then we put this whole limit, we're always putting it all over the variable h. Okay, so I notice in the numerator, I can simplify. I have a 5 minus 5. Those are going to cancel each other out. And we have the limit as h approaches 0 of -h squared plus 2h all over h. If you went and did direct substitution right now, and you plugged in 0 wherever you saw an x, I'm not an x in this case, h, notice that you're going to get 0 over 0. So if we got that form 0 over 0, that didn't tell us anything, and we had to go back and manipulate it. So notice that in the numerator, they both have a factor of h in common, and we can factor that out. So I'm going to bring down the limit because I haven't used it yet. Going back in to manipulate it. So pulling out this h from -h squared, I would be left with a single h plus, and then if I pull out an h from this 2h, then I'm left with just a 2. This is all over h. So notice we have like factors now in the numerator denominator that we can cancel. And so we're left with a limit as h approaches 0 of negative h plus 2. So now when we go in and do our direct substitution, things fall out really nicely. And so going in here, we get negative 0 plus 2, which is equal to 2. Okay, so what we just did was we just found the instantaneous rate of change on our function f of x at x equals negative 1. So again, that's the slope at that value x equals negative 1, and it's actually the slope of our tangent line. So we have m equals 2 is the slope of the tangent line. And the question asked us to find the equation of the tangent line. So we need the slope of the line, which we have, and we need a point on the line in order to find the equation. Well, remember, we already found that point. We knew when x is negative 1, our y value is 5. So we have a point at negative 1, 5. So it's up to you on how you want to find that equational line. You can use your point slope formula, or I prefer, again, the y equals mx plus b. The point slope form, we know enough information that if we plug in our values for our point y, so our y value is 5, is equal to the slope. Well, let's go. Our slope is negative or positive 2. All times x. So our x value, go to your point, our x value is negative 1 plus b. So we have an equation, one variable, we can figure out what b is. We have 5 equals 2 times negative 1 is negative 2 plus b. We need to solve for b, isolate it, add 2 to both sides, we get our b is 7. Okay, so we have our, not yet, we haven't written it yet, but we can write now our equation of our line. We have our b value, our y-intercept, and we have our slope, 2. So go back in and just plug in your slope and your b value, and then we'll have the equation of that line. So we have y is equal to our slope, which is 2, times our x value, plus b, and b we just found was 7. So this is the equation of the tangent line at x equals negative 1 on our function f of x. So I still have Desmos up from our last example when we graphed the secant line on our function. Let's just go back now and let's graph this equation of the tangent line at x equals negative 1. Okay, so I pulled up Desmos. We have the parabola is our original function 6 minus x squared. We had to find the equation of the secant line. So that was the blue line here between x equals negative 1 and x equals 3. Let me get rid of that one now. So you don't. And then we just found the equation of the tangent line when x at x equals negative 1. So if we look at the point there, you can see that that point on the graph and that line is negative 1, 5, which we had found. And then we have the equation of the tangent line that goes through that point. So again, like imagine that you were driving, and if you were going from left to right and your headlights, notice, are facing up like that. And that line kind of forms that equation of that tangent line on the graph. So let's look at one more example of finding the equation of the tangent line at a particular point on a function f of x. So in this example, we're given that f of x is equal to the square root of x. And we want to find the equation of the tangent line at x equals negative, not negative, at x equals 25. Okay, so again, there's two things that we need for a line. We need a point. Well, we're going to find that point at the x value that we're trying to find the equation of the tangent line at. So we want to look at what is f of 25. So we're going to go into our function f of x, and wherever we see an x, we're going to replace it with 25. So we have the square root of 25. And the square root of 25 is equal to 5. So we see that we have a point at x value is 25, my y value is 5. And then the second thing that we need the slope. And in this case, because it's the tangent line, the slope is equal to the instantaneous rate of change at x equals 25. And so let me write it with a limit. So our slope in this case is equal to the limit as h approaches 0 of f of a. Our a value in this case is 25. So let's just write 25 in there. So 25 plus h minus f of a, but again, a is 25. So f of 25 all over h. Okay, so we can do that. You can do it in pieces, or you can just throw it all together. And let's just throw it all together here. So we have the limit as h goes to 0. So first looking at f of 25 plus h. So you're going into your function again, but this time wherever you see an x, you're replacing it with a whole expression 25 plus h. So we'll have, this is equal to the square root. I see the x there, replace it with 25 plus h. Then we have this minus f of 25. We actually found f of 25 right here, right? That f of 25 was 5. So we have minus 5 all over h. So notice if you plug in 0 for h there, we have a problem, Houston. We have 25 plus h underneath the radical. That's going to give us, and plugging in 0 for that h, that just gives us a square root of 25 minus 5, and then all over 0. And notice we again get an indeterminate form of 0 over 0. And so that's where we had to manipulate it. And notice that this had a radical in the limit. It was a rational expression with a radical. And so we could get rid of that radical. The trick we learned earlier was to multiply by the conjugate. So the conjugate of the radical 25 plus h minus 5. That was the opposite sign in between the two terms, two groupings. So there was a minus in between, so the opposite sign is a plus. So 25 plus 5. But we can't just multiply the numerator by that because that changes everything. But we can multiply this whole thing by a fancy 1. So we have to multiply the denominator also by that. So we're going to use the fact that we just wrote something in the form of a minus b, which was in the form of a minus b, times a plus b. Instead of having to FOIL all that out, that, recall, is just the difference of squares, a squared minus b squared. So let's use that fact. So when we expand that, we can just square the radical. So the square root of 25 plus h, that quantity is squared, minus our b value 5, and that quantity is squared. All over. We're not going to distribute here. If we distribute, then you're going to see you get 0 over 0 again, and you're going to have to factor out the h. So let's just leave it out there. So we have the square root of 25 plus h, and then outside that radical, we have that plus 5. Okay, so we have the limit, h goes to 0. Square root of 25 plus h quantity squared. Square and square root cancels each other. We get 25 plus h. Minus 5 quantity squared is 25. All over h, all times the quantity square root of 25 plus h, outside plus 5 in quantity. So notice those 25s cancel. And once that happens, notice now we have just an h in the numerator, and we have a single h in the denominator, and those h's will cancel out. So really we have the limit, h goes to 0 of 1 all over the square root of 25 plus h plus 5. So now when we go in and do our direct substitution and plug in 0 wherever we see an h, notice it falls out and gives us a number. We have 1 all over the square root of 25 plus 0 plus 5 outside. So 1 over the square root of 25 is 5 plus 5. So this is 1/10. So we just found our slope, our instantaneous rate of change at x equals 25. We had found our point above was 25.5. So now if you plug this into y equals mx plus b, we can find out what the equation of the line is. So our y value is 5, is equal to our slope, which we found to be 1/10, times x which was given to us, was 25 plus b. Okay, so I notice, let's simplify 1/10 times 25. We have like factors in the numerator denominator. We have 5 in common. So 5 goes into 10 twice, 5 goes into 25 5 times. So that gives me 5 is equal to 5/2 plus b. So I need to get b by itself. And to get b by itself, I would subtract 5/2, but I noticed that it's a fraction. And in order to add two numbers and they have fractions, we need a common denominator. So at the same time, let's multiply 5 by that fancy one with a common denominator of 2. So this would give me 10/2 minus, I'm going to subtract this 5/2 is equal to b. So 10/2 minus 5/2 is 5/2 is b. So now we have the equation of the line. We know what our b value is. We know what our slope is. Plug those into y equals mx plus b, and that's the equation of our tangent line. So y is equal to 1/10 times x plus 5/2. Okay, so we just found the equation of the tangent line of square root of x at x equals 25. I'm sorry, I kept you guys over a little bit, but I wanted to get through that example and I didn't want to rush too fast through it.